When working with bases other than 10 for the first time, it's a good idea to try counting in those bases to see how the system works. So in our commonly used base 10 system, or the decimal system, we have digits from 0 through 9. So here I've made a list of those numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. When we get to our last digit, then we put a 0 in the ones place, and we carry a 1 over to the tens place. And then we continue on 11, 12, and so on. So we're going to see how to do that with different bases. So for this first part, we're just going to be counting to the number 10 in base 10 in these other bases. So in the hexadecimal system, this is base 16, so our digits go from 0 to F, and F represents 15. So when I start counting, this is going to be very similar to the decimal system. So 1, 2, 3, 4, and so on. But when we get to 9, we still have digits. So we start with A, which is equal to 10, and then we would continue on B, C, D, until we get to F, which is our largest digit in hexadecimal. But since we're only going to 10 for the moment, I stop at A. Now let's take a look at the octal system. Because this is base 8, which is a number smaller than 10, this is going to be a little different. We get to our largest digit before we get to 10. So, 1, 2, 3, 4, 5, 6, 7. Notice that the largest digit is always 1 less than what the base is. So in base 10, the largest digit was 9. In base 16, the largest digit is F, which is equal to 15. So we're up to our largest digit. So we're going to put a 0 in the ones place and a 1 in the eights place. So we have one group of 8 and 0 ones. And that makes sense here because what is this equal to? It's equal to 8 in base 10 and also 8 in base 16. Okay. And then we continue on with one group of 8 and 1, 1, which means 9, and one group of 8 and 2 ones, and that's 10. Okay, so that's our octal system. Now let's take a look at binary. These numbers require a lot of symbols because our largest digit is 1. We only have digits 0 and 1. So when I start, I have 1, and that was my largest digit. So next we're going to put 0 in the ones place and 1 in the twos place. So we can see this is equal to 2. And then we have one group of 2 and 1, 1. That means 3. And now I'm at my largest digit again. So I'm going to bring down a 0 because we're increasing by 1. And I carry a 1 over. 1 and 1 makes 2, which is 0 and 1. So what we have here, after having one group of 2, imagine it this way. We have one group of 2, and then we have a single 1. So if I add another 1, now what do I have? I have 2 groups of 2, or one group of 4. So since we can't say 2 groups of 2, we have to say one group of 4, and then no groups of 2 and no ones. So with 5, we have 1 group of 4, 0 groups of 2, and 1, 1, because 4 plus 1 gives me 5. And now I'm up to my largest digit again. So when I add 1, I'm going to be at 0. I carry a 1. So there's 1 here. So that's 1 group of 2 and 1 group of 4. And 1 group of 4 plus 1 group of 2 makes 6. And then to get to 7, I can easily just put a 1 there at the end instead of 0. And now I'm at my largest digit again. And so what I can see is I have 1 in every place value. So this is going to turn out to be 1 group of 8, no 4s, no 2s, no 1s. So now we can see that matches up with what we had in the other bases, right? So in all of these, we're seeing that we have 8 individual objects. So 8 in decimal represents 8 objects, same thing in hexadecimal. In octal, we're saying we have 1 group of 8 objects and 0 left over. And then in binary, we have 1 group of 8 objects and 0 4s, 0 2s, and 0 1s. So to continue in binary, we have 1 0 0 1 and then 1 0 1 0 because we added 1, so then we had a group of 2, and we bring that over as a group of 2 and 0 1s. So that's how we get from 1 to 10 in those 4 different systems.